Hello, how's it going? I decided I would do a little mini-series on concurrent programming. Why not? So here is what I see as like the fundamental problem in programming, in game development. It's like a threshold we need to cross through. There is just a lack of beginner-friendly information on programming multi-threaded stuff. And it's not really helped by the fact that anytime it comes up, the default response is multi-threaded programming is hard. It's like, okay, that's true. But pop quiz, what's the quickest way to stop people from learning multi-threaded programming? Now, this series is going to think of it like, I say 1 week here, it's like 1 weekend. Honestly, it's just a brief little crash course on a bunch of parallelization techniques we can use, and it's all going to be done through the lens of raycasting. So you can see here, this is an image. If you look up Lode van der Veen's tutorial on raycasting, it's the classic tutorial that a lot of beginners sort of start with. We're just going to be taking that program and applying various techniques to it. And here are the techniques that we're going to be applying. First up, we're going to be doing SIMD, single instruction, multiple data. Then we're going to be using a library called TaskFlow, which is just a really useful way of doing multi-threaded programming. It makes it a lot easier. And then ultimately, we'll be using the GPU to do this job. So as a spoiler alert, all the code right now for all these stages is up. There's no secrets. It's there. You can jump in, have a look at it. I'll show you what we've got. So just as a preview, this is what we've got. We've got this raycaster. We can, walk around and stuff. That's pretty cool. What do we got here? Like 400 frames per second? And that's decent. 400 frames per second is nothing to scoff at. But, life is good, but it can be better. So this is what we start with at the beginning of the series. And then, we'll have 3 more videos and then this is what we'll have by the end of the series. Now you see, the colors are a little different. They're shifted a little bit. That's not a big deal. The big deal is the frame rate. So we've gone up to like 7,000 frames per second. So if you want to learn the techniques to take a program from 400 frames per second to 7,000 frames per second, spoiler alert, just put it on the GPU, but this is stuff we're going to be talking about in this series. And this code is available right now. You can jump in and use it. But yeah, there you go. That was your little teaser. This is what we'll be doing. Again, simple series. This was the intro video. We'll have 3 more videos. We'll be going through each of these things. I will be explaining the concepts and talking a little bit about little extensions that we can do. So, for this video, homework. Like I said, the code is linked. The GitHub repo is linked. You can jump in there, grab the code, have a look at it, set it up, make sure it's working on your machine, at least the start of it. I would also recommend having a look at the tutorial by Lode. Again, Lode raycasting tutorial. I'll put a link to that as well. And the reason is that in this series, we're going to be taking that code as a given, and then we're going to be modifying that code. And it's not super important to understand every single step of the algorithm. The basic idea is we just have a big for loop for every pixel horizontally on the screen. And then for every X coordinate along the screen, we cast out a ray, interact with the world, determine how far it went, and then draw a little line segment. That's it. But in general, for every algorithm, you start with the algorithm, then you parallelize it, and understanding the algorithm gives you more opportunities to see ways that it can be parallelized. So I hope that this has gotten you excited. I'm pretty keen, and I will see you in the next video. I'll try to do 1 of these per day, so 3 days. All right, have a good one. See you soon. Bye.